So where do we go from here with the Mathematicians' Lament? There's a lot more that could be said. We talked in the video yesterday about some of the challenges around math education. Math education is fundamentally broken, Paul Lockhart would say. We have this assembly line curriculum model driven by standardization, not meaning. Our students are not able to make connections between what they're learning. Now, I'm adding a little bit of my footnotes here, but are your students able to make connections between what they learned in Algebra 1 and how it connects to what they're doing with Algebra 2 concepts and how it connects to pre-calculus and how it connects to calculus? Students need to see the big picture. The assembly line model has some problems there. There's a lot of procedures sometimes and not enough of the conceptual. We talk about here's how this can be done, but what about the why? I was helping a student to derive a unit circle, and we started getting into the fact that they don't have to memorize the unit circle, they just need to learn how to derive the unit circle. If they understand the why of how to convert degrees to radians and radians to degrees and the special triangles and how to use that to help them derive the sine 45 and cosine 45 and sine 30 and cosine 30 and so on and so forth. I want to encourage us to help our students learn the why. Unfortunately, there's a loss of curiosity. Because of the testing pressure, students don't have time to be curious. Also, they don't want to fail. There's a fear of failure. Some of them have disengaged. They're literally doing math because we tell them to do it. It feels like something we're doing to them rather than something they want to do. The key limitation in the Mathematicians' Lament, however, is that some people say that there's a strong critique, but there's no scalable implementation. That's part of where we want to come in. We want to provide steps for schools to implement the Mathematicians' Lament. Train teachers, even train parents on math education things so that parents can better support their children. And so we need to provide a scalable implementation. We have a diagnosis. What is the solution? Well, the solution involves, number one, recognizing that how math is done right now is not healthy. It's not healthy. It's something where we've removed the beauty and the passion and the excitement that could come from math. We've removed a lot of that because of this utilitarian, like you have to learn it because of, passing the state standard and so on and so forth. We don't need to worry about that anymore. We still need to help children learn at the highest levels, but we should focus maybe more on their mastering of concepts and recognize that if we don't do the summer break, the children can go much further. So math education, unfortunately, is failing at scale. Students lack deep understanding, and therefore teachers need to step back. And I believe the elementary school teachers, the middle school teachers, and the high school teachers all need to be talking to one another and having conversations about how things are flowing from one to the other. Math needs to be taught as one story. Automation, there's a lot of automation that can happen with basic computational principles, especially later on in like 11th grade, 12th grade. We really have to focus on the conceptual, the depth of understanding, the why. What was the context that gave rise to the concepts that students are learning? We need to focus on fluency and depth and application and the history and philosophy of mathematics, and we need to scale all of that. And I believe that it is very doable, but it's going to require some work. But we know how to work though, right? Have you been to a sporting event in America? We take sports very seriously. And I play tennis and soccer, ping pong, and basketball. I'm an athlete. But I don't think that, we can have both. We could put passion into sports, but we can also put passion into mathematics and education. But it's also becoming a national security issue. The country that has the best mathematicians is literally going to push the boundaries of technology much more effectively. And America, we have some work to do. We can do this. So I'm going to propose counting to calculus as a solution for implementing the principles of a Mathematician's Lament, but we can look at other curriculums over time. So in counting to calculus, what I'm trying to do is I'm giving every parent, every teacher, every student a roadmap from pre-K all the way to calculus 5 as a story. So they can find where they are in the story and just keep learning and keep growing. It's a mastery-based curriculum that also encourages people to look outside of math into the applications of the concepts they're learning, which could be from science or other fields that the math is tied to, economics. So it's a mastery-based curriculum. It has workbooks and it has textbooks that follow the workbooks, but you can use different textbooks without journals. That's fine. The point is our students have to write. They have to take notes. And so we want students to learn at the pace of their mastery. We want to equip teachers to handle a wider span of concepts in mathematics, because again, math is like a story in how we're trying to teach it. It's supposed to be like a story, but there's too much fragmentation. So how do we fix the fragmentation? We want students to explore, discover, practice, apply, build, use the knowledge they've acquired to do something, not just learn for learning's sake. What are you doing with what you've learned? If you want, we have diagnostic tests. We can diagnose exactly where every student is at, what are the concepts they're struggling with, and how can they be fixed. We want teachers to step in to help fix the gaps and help the students to flourish. We want students to be confident mathematicians. We want them to master. We want them to be problem solvers. We want them to solve practical problems in their communities. For the schools, you have a higher performance, engagement, differentiated learning based on the mastery level of the students. We help people set all that up within their school system. So for example, when it's math time, you can have, let's say in a middle school, 5th to 8th graders, you can have a math class that is pre-algebra, and everybody who needs pre-algebra goes to the pre-algebra math class. Everybody who needs algebra goes to algebra math class. Everybody who needs algebra 2 goes to algebra 2 math class. And yes, we said algebra 2 because in counting the calculus, we realized that pre-algebra and the topics we teach from 4th to 7th grade, the repetition is actually not good. It's too much. Too many kids begin to check out. We have too many places in our math curriculum that make it so that students literally want to just check out. And so in the 4th to 7th grade, if I've already mastered fractions and if I have my notes from fractions, why am I learning fractions again in 5th grade and then in 6th grade and then in 7th grade? We have to be careful not to give people too much of something that will get them to a point where they're like, this is boring and pointless. That is what I hear and I've heard from many people through my 20 years of teaching. 15 years more with middle school, high school, and then before that I was a tutor at the math lab. So we need to help students learn, master, and then keep moving along. That mastery-based model is what will help students reach their full potential. So you don't have people who are bored and you don't have people who are frustrated, which is what we have in a lot of math classrooms in America. So we give a diagnosis. We can do a diagnosis of your school's math curriculum. We can train your teachers. We can show you how to, have a robust math program that implements books like a Mathematicians' Lament, books like a Mathematician's Apology, and then we provide coaching to your teachers year-round. So if you want us to work with your school to raise the bar in math education and help your students love mathematics, then give us a call. That's what Counting the Calculus does. So if you have any questions, thoughts, comments, objections, please do not hesitate to reach out. But I look forward to continuing to post regular videos about a Mathematician's Lament. I encourage every teacher to please read a Mathematician's Lament, and then please feel free to like, share, and subscribe to more of the videos we're doing in this series. Thank you again. My name is Amos. I am a medical physicist, a math and science curriculum writer, and my goal is to help 1 billion students to love mathematics. Why? Because math is beautiful. Thank you, take care, and have a blessed day.